task. Okay, I think that we can start maybe. Hello everybody, and this is the first webinar. Let's see how it works, and I hope that we will have a nice presentation, the first webinar of EIOPA. Will you pass the slides, Marcus, please? Okay. In this seminar, we would like to explain the details of the different progress with the XBRL development, mainly the things that we already did and the things that we are going to do. The seminar is, as you can see on the screen, the seminar is divided in 4 parts. The main part, the general introduction, will be done by me, and I will speak mostly about the timelines and the status of the projects. Most of you already know, but I will speak again. The second part is done by Michael Skopowski, and he will speak about the data point modeling exercise that we did for Solvency II, and that we already published on the website. The third part is for Bartos. He will explain about the implementation and the proof of concept of the Solvency II taxonomy, and he will make some examples. He will give some examples. At the end of each part will be a rounding question of answers, and you can raise your hand. There is a tool in this platform when you can raise the hand, and I will activate the microphone, and you can write your questions. Let's pass the slides, Bartos. One more. Okay, this is the general timeline that we have. It's the same timeline from time ago, and you can see that probably you know that there are some political movement regarding the entering force of Solvency II. In spite of that, we are going to keep the same timelines. We want to have the taxonomy ready to enter in force, ready to pass to the production phase, and this means that we are going to keep the same timelines. If there are new business changes, we are going to include in the taxonomy. We are going to include them in the tool if needed, but we are going to keep the same timeline that we have. Let's see what happened with the real entering force of Solvency II, the date of entering force. Until now, the most important deliveries have been the publication of the DPM for the World Solvency II framework. This includes the annual, the quarterly, the group, the solo, and also the public disclosure reporting. In the future, we are going to include also the financial stability. During this exercise, we also did some kind of normalization and normalization of templates. In fact, there is now only one workbook that is covering all things, and Michael will speak in details about it in the presentation. The second delivery that you can see is the publication of the proof of concept. That was more or less at the same time of the DPM. This proof of concept is covering the moderate dimensional and the highly dimensional. It has 2 layers, moderate dimensional and highly dimensional. It's something that we want to explain today in details, why we have 2 layers, what is the benefits of this, why we think that this could help to the national supervisor, to the insurers, and that will have some benefits to all of us. Before end of the year, maybe early 2013, we are going to publish the World Taxonomy of Solvency II, covering all the templates and align it with the latest business requirements. Sorry. This means that up to this moment, probably we will have to wait for the new business requirement, but in this moment we will be aligned with the last business requirements, ready to pass to production phase. Regarding the tool for undertakings, as you know, there is we will provide a tool for free to help to the small undertakings with the first implementation for the first reporting phase of the XBRL reporting. This development will start on January 2013, and we're hoping that we are going to have a first beta version covering the core functionalities of the tool by mid-2013. On September, October, we hope that we will have a full theater tool. Also, maybe we will have later on more iterations, and depending on we want to have some kind of test of the tool, and maybe there will be more improvement. But by September of the next year, the tool should be ready. Will you pass the slides? Okay. This is the current status of the project. Used to show you. Regarding the tool, we are in the procurement phase. There is nothing specific new. Probably on end of the year, we are going to be able to provide you more information about how the tool will be, because now it's just some requirements, and it's depending on the contractor and how his approach, the tool could be in one way or another. And this is the main rep for the reporting to fund the techniques. Could you pass, Marcos, please? Next slide. Okay. For the taxonomy development, I already commented, but I also want to focus on two things. One thing is that in midterm, we are going to include, this means in the following months, probably in the following 3 or 4 months, we are going to start to work with the different subsets that will have the taxonomy. As you know, there are a number of subsets. Also for long term, we are going to cover maybe the pension funds, if it's the case, or other taxonomies if needed. Also, there is, we already ran a procurement for a quality assurance, a quality check of the taxonomy. We are going to start to work with this provider at the end of this month, and for this implementation of the taxonomy, we are going to have another external team to check what are the deliveries and how is the process done, and so on. This is maybe the two big news that we have now for the taxonomy. And this will be my presentation, my introduction. And could you pass the slides, Marcos? This is regarding how is the development process. I already speak about this, but we have an analysis and a data point modeling layer or process, the taxonomy development, and the quality assurance. As you can see, we are covering all the aspects of the process, and later on, VRG will speak more in detail about how the process is done. And that's all for the presentation. Could you pass, Marcos, please? And now Michael Skopowski will speak about the data point modeling. If there is any question regarding the timelines, I already did, please raise your hands. You have your option in the tool, and I will activate your microphone. No questions? Nobody has questions? Okay, Michael, go ahead.
Okay, so let's start to describe the DPM methodology and the results of this process of DPM creation. In general, modeling the data was always a challenge, and in fact there are multiple ways how to model the data. At least 2 of them are applicable, or 2 of those methods are possible. One of the methods is the form-centric approach. Let's imagine that we have a part of the balance sheet of the entity which is Watermelon, and it is, as we see, the balance sheet, and we have some additional information that it is consolidated, audited annual report. We know that the values are in millions US, and we know that for the end of the year 2011, the value of the cash and cash equivalents was 10,339. Please mind that we can assume in this case that this value gets its meaning, this value gets its semantics just because of the location of this information in context of this table. So without this table, this value has no meaning, and if this information would be reported in another template, it also would create some consequences as, for example, not a clear idea of what is the content of this value, what is the understanding, what is the meaning of this value. So the second approach is the data-centric approach. It means that the data should be fully understood by its own and all of its property. And the matter of the location of this information in the template, if this template number 1 or template number 20, as long as we have this information, we should exactly know what it is. So the same information as we had previously, we have in this data cell. Later we will call it data point. And we know all the properties of this information. We know that this information, this data point, it is in our case the concept cash and cash equivalents. It is for the period for the end of the 2011. It is for the entity with this number, which refers to the watermelon entity. These data are consolidated, and also we know that this data is audited. But please mind that as the form-centric approach is pretty simple to model, the data-centric approach is much more complex because we have to know the origin and the consequences of every information, every property in our data model. Let's imagine then that, for example, we have to model this simple table. In fact, this is the part of the Solvency II balance sheet. And as we know, or as we see, it is all about the liabilities. We have different kinds of the technical provisions in different rows. And in the titles of the columns, we have the information about the valuation method for those technical provisions. We know that we have Solvency II valuation or statutory account valuation. As I was discussing based on the previous slide, we have a lot of different options. The first, and it seems at the very first moment the simplest option, is to say that each data cell is a different primary item. It is a different basic concept. What does it mean? That in this case, to know what is exactly the meaning of, let's say, this LS1 data cell, we have to gather all the information from the description of the title of the table, from the rows and from the columns of this cell. So it would mean that this LS1 data cell, it is the liabilities, in fact the technical provisions for non-life excluding health, evaluated according to statutory account value. As you see, almost everyone could model the information in this way. So it's very easy to model at the very first moment. But please mind that during most of the projects or or in time, a lot of information or reporting requirements changes. Let's imagine that in few years the statutory account value will have to be identified, or for example as international financial reporting standards, or let's say local GAAP, for example Polish GAAP. It would mean under this scenario that all the data cells that we have in this column have to change, because it will be liabilities, technical provision, non-life excluding health, IFRSs, or technical provisions, non-life excluding health, Polish GAAP. So under this approach, it would be very easy to model at the very first moment, but to maintain it, it would be very difficult. Even very small changes to the reporting requirements or to the underlying documentation would have potentially huge consequences. So what would happen if we would assume that some information that could be easily changed across time would become not the primary item, but the property of another item? Let's assume then that on the left-hand side we have all the items that we know, and the properties of those items would be Solvency II value or statutory account value. So the property will be the valuation method. In this case, if the valuation method change, then the basic concept would behave still very stable. But this is just one of the ways how to model this information, because if we know exactly what is reported in this template, then we shall know that in fact these basic concepts, they are not, let's say, generic business concepts. In fact, we have a lot of information also in this case. We shall know is that we have the information about different lines of business in this case. So we can see that here we have non-life, which could be non-life excluding health, health similar to non-life, and so on. So in fact, theoretically, we can identify here at least 3 different properties, not just one. So the first property would be valuation method, Solvency II and statutory account. The second would be lines of business, and as you see, we have a number of lines of business. In fact, in the Solvency II regime, the set of lines of business is even longer. And then we have the possibility to verify the valuation of provision. Is it calculated as a whole or not? And if not, is it best estimate and risk margin? And the second important issue in this case is that at the moment we have solved only those issues that were pretty clear from the first moment we saw this template. But in fact, there is a lot of information hidden from us at the moment. One of the simplest information that we would have to specify more is, for example, is it group or solo reporting? If it's a group reporting, then what is the consolidation scope or consolidation method? Is it, for example, some aggregation, deduction and aggregation method, or full consolidation? Or, for example, is it the consolidation only for the insurance, reinsurance activities, or some other activities? So the set of questions that we would have to ask to specify the content of each data point is much wider than we have discussed so far. But if we will identify all the characteristics of all the information that have to be reported according to our reporting requirements, of course based on the regulations, and having in mind the data model identified, for example, as a set of templates to be reported, then we are able to specify in every case, in case of every data point, where this data point is reported, and potentially how it is broken down by different properties. For example, we can identify that in one template, let's say VA-C2C, we have the information about the technical provision calculated as a whole for a life business for the current year. But this is exactly the same data point, but divided in a little bit different way in the case of the balance sheet. Because in this case we can see that in fact it is a sum of 3 concepts. It is the sum of the technical provision for the health similar to life, calculated as a whole, for a life excluding health and index link and unit link, again calculated as a whole, and index link and unit link calculated as a whole. But again, this is not only the case when we can identify such a thing. Also in the technical provisions template and F1 template, we can identify similar data. So one of the most important benefits of the DPM is being able to verify the relation between the data cells and entire set of the templates to be sent to them for the supervisory purposes, for example. So the DPM is template independent. It is data-centric model, as we were discussed previously. It is very explicit about the content of each data cell to be reported. It is very easy to trace the difference between every set of data points across entire templates. So it's easy for us to know what property creates the difference. Maybe it is just one property, as on this example, that only the line of business changes the values across different templates. But maybe there are also other differences in other properties, not only lines of business, but also valuation method, maybe also some sectoral breakdown. The next thing is that DPM could be a guideline for people who would like to model the information also in the PI systems according to the hierarchies or according to the structures that are identified by the people who prepared the DPM. And in fact, this is the business experts, in this case of EIOPA, who did it. The next thing is the quality of the reporting requirements. because in this case, every single data has to be expressed using a common dictionary, which we will discuss in a second. It means that every differences or every issue that will be discovered during this process have to be solved. So that means that the data and the template in the end have a very good level of quality. And last but not least, this model is very stable, because the basic concept, the basic items according to this methodology are very generic, so they are very stable in time. And on the other hand, because we are using the properties that we are able to define, especially in the hierarchical structure, it's easy to extend, but it has to be extended according to some business logic. So the logic of the model that already exists cannot be broken, which of course makes the model easier to maintain across time. At some moment, some templates, especially for the people that have no that deep business knowledge in the data models, for example, as Solvency II, some business concepts seems to be very difficult. Let's imagine, or let's see the business concept that was used in one of the frameworks that the data point modeling was applied. And the data point was the net carrying amount of not yet unimpaired but already past due over 180 days, debt securities held, issued in euro by monetary financial institutions located in European Monetary Union, with original maturity under 1 year, measured at amortized cost, and relating only to business activities conducted in European Union as local businesses. So as you see, the data to be sent, it is just one, should be just one single value. But to understand exactly what shall be, how to create this value could be difficult. When we create the hierarchies, when we create the basic concepts and all the properties that are applicable to the basic concepts, the universe of potential information is of course huge, but to say what is exactly to be reported, it is quite easy. And in this case, we can assume that first we have a set of basic concepts. In this case, we can later refer it as a domain. So it is a set of different domain members, just like basic concept assets, liabilities, equity of balance sheet or exposures, and so on. So it is quite easy to identify that in this case, it is the base term, it is an asset. Another property that could be identified in this case, it is the category of asset. As you see, we have here some subdomain of different categories of assets, and we see that the total assets could be cash, loans, debt securities, equity instruments, and so on. So again, it is quite easy to say that from different types of assets, we mean exactly at this moment debt securities. From which portfolio? Again, we have a set of different portfolios in the hierarchical structure, so we know exactly how to make a difference between what we have in this data point with what we don't. And we can say that it is amortized cost. In case of amount type, we know that it is carrying amount, not some other like notional amount or accrued interest. From the impairment status, we know that in this case you are asking about the unimpaired but already past due. So from impairment status, it is unimpaired. But from the past due periods, we know that it is more than 180 days. The next thing, it is the original currency, and we know exactly that we mean the original currency only euro, and original maturity less than 1 year, and so on. So the counterparty, we can see from our example that is monetary financial institutions, so the property of our data point, it is MFIs. From the counterparty residence, it's European Monetary Union. From the location of activity, it is only European Union. And of course, we need to know what exactly the data type is expected to be reported. So from the metrics, we have to pick up not text or the data, but everything that we are asking is this data point or the data that we are asking, it is monetary. So when we have this data point defined in that way. For us, it is the secondary matter where this data point is reported. It could be in some static view, it could be in some dynamic view, it could be in the template number 1 or 51. It doesn't matter for us as long as we know exactly what is this data point all about. So what is the data point modeling in general? In fact, it is splitting the information in some logical pieces, just like different properties or different basic concepts. And when we know exactly what different building blocks do we have, then it's easy for us to build whatever template, what we want, and not only to build it, but know exactly what goes where in this template and why. So it seems to be very similar to Lego blocks. Of course, everyone could have some Lego blocks in some basket, and based on that to build some plane. So in our case, some report. But only if the building blocks that the person is using are somehow organized, only then this plane or our toy will resemble the plane itself. And this is all about the modeling. But only if the modeling will be to every single piece of the information, every single detail, and all the information will be organized in pretty well way, only then we can build something that will resemble for us something like a masterpiece in case of Lego. So in this case, if we want to know exactly how to build a report and what is to be reported in this report, and we want to have it easy to maintain and easy to analyze, we have to first build the universe of potential information to be used. So this part of our slide, it is in fact the universe of the information. We call it sometimes it is our dictionary, or in the files that you will see on the Eurofiling web page, we usually call it DPM file. And the way how to model this plane, in our case, it is annotated template, because annotated templates gives you explicit information what data or what property is reported where and with which value of this property. So how the DPM development process look like? First of all, we have the templates and all underlying documentation that we have to analyze, and based on that, all the initial decisions could be taken. But please mind that it is just the first step of DPM development process. And the business knowledge in this area, if you want to have the proper DPM or a proper model, it is crucial. Based on that, we create this universe of potential information, which we call the DPM file, or also we call it the dictionary of the information. In the moment, I will show it how it looks. And based on that, if we know what exactly are the building blocks of our information, we are able to normalize and annotate the templates to identify in every data cell what goes where from our dictionary and why. We call the second two artifacts. It is in fact the DPM artifacts, and I would like to discuss it in detail on the case of the Excel. Just give me a second. So first of all, the sets of the template, the sets of the files that we are showing right now are of course available on the EIOPA web page. So we have the Solvency II TPM annotated templates, where we have the first draft of entire TPM and the annotated templates for the Solvency II project, and the preliminary information on the EIOPA Solvency II TPM and XBRL taxonomy framework architecture, which we usually call the PoC, as it is related only to the three of the sets of the templates of Solvency II, but it shows all the important aspects of the architecture also in case of the XBRL methodology. So starting with the Solvency II PoC annotated template, we first have to know what is the dictionary of the information that we use. As you see, it is organized in the Excel file. We know what is the owner of the model, so we know that it is EIOPA. Potentially, of course, later it will be also identified in the XBRL taxonomy. The next thing, it is different baskets of information that we are using. So here we call it domains. Those are the sets of the data that we have in our model. For example, different lines of business or different consolidation scopes or different amount types. The next important thing is the dimensions. And the dimension, it is in fact the perspective to analyze the content of domains. For example, in the domain we can have information about the, let's say, currency, but in fact the same currency, just like euro, it could be original currency or remaining currency, and in this case, this perspective we call dimension, and we have it under the dimensional information worksheet. Of course, all the information about the concept of dimensions, domains, domain member, you have also available on the EIOPA web page under this set of documents related to the PoC, and you can find there also data model components in case of in this case the dimensions, domains, domain members, and other important issues. So just to recap, in the domains we have different sets of domain members, but it is dimensions that identify the way how we would like to see those domain members. So the same euro from currency domain could be original currency, or for example reporting currency according to the dimensions. For example, here you have original currency, or currency received, or currency delivered, settlement, obligation currency, or reporting currency. They refer to the same. They can refer to the same sets of domain members from the domain currency. Later, we have the information about different metrics. The information about metrics gives you the information about the data type. So the metrics could be monetary, string, date, integer, decimal, and so on. Next set of information, it is different domains with their members. For example, let's focus for a moment on the domain lines of business. So here we have entire set of lines of business, which are, so this is the domain, and to the right-hand side, on the right-hand side, we have different subdomains which can have hierarchical structure. So, for example, we can have insurance classes, and as you see, we have a hierarchy of insurance classes. It could be total. The total could be non-life or life. The non-life could be accident and sickness, motor, and so on. The information about potential relation, for example, arithmetical relation between those members in the hierarchy, is identified by sign and weight. So in this case, we know that the total is equal to non-life with a +1 and life with a +1 weight, and so on. So for example, on the next level, non-life is equal to accident and sickness with a weight +1, with motor with the weight +1, and so on. So as you see, we have full information about the relation between members in the hierarchy, and then when you use some kind of, if you use those properties in the description of the data point, then you can find, as I said previously, the relation between them. You have also the information about the dimensions that are applicable to these subdomains. So, for example, this dimension, which is the classes of business, are identified also here. Sorry, classes of insurance. In many cases, in the column comment, you will find the information about the table from the Solvency II set of templates where this subdomain is used. Especially when we will go, for example, to the, when we go to the main categories, you can identify in which templates, IGT1, IGT2, and so on, the type of transaction is used. So from this set of information, we know exactly what are the building blocks of our information. Another set of information, it is a different type of domains. So far, we were discussing only the domains with the predefined number of members. In some cases, it's not important that it is not the case that we have predefined sets of members of the domain, but we have limits only related to the type of the member, and it is according to the reporting institution, for example, what value or what member it will be. We can say that in this case, it is about the type domains, and usually in our model, when we have some kind of codes, IDs, and so on, it's according to the reporting entity. It could be according to the reporting entity what ID it shall identify for the set of data in the table. So this is entire set of the information, the dictionary that we use to be able later to specify what is where in our tables. So, for example, when we will go to the annotated templates file, we can find the balance sheet. And in case of the balance sheet, from our example that I showed you a few minutes ago, in our example we have this part of the information, and we know from the description in rows, columns, and I will show you in the second also in the z-axis, we have the value of every single data cell. So, for example, we can see that this particular data cell, it is from basic concepts liabilities, from the types of the liabilities and equity, it's gross technical provision. From lines of business, it is non-life and health non-similar to life. From the valuation method of provisions, it's total. And in the same time, we have a description in the title of column. And here we have a very specific annotation, which is all members. So first of all, we have information, what is the domain used, what is the dimensions related to this domain, and then we have the information that it is so-called drop-down lists. In some cases, when we have already the predefined set of members in the domain, we would like to be able to pick up one of those options from some kind of a list. Let's imagine that we have in the table for every single asset identified the country of residence of the issuer. If we have already in our model the countries of residence, it is possible to pick up the member from the list. According to this annotation, we can say that it could be all members from statutory accounts or all children of statutory account member. So just to show you how it works, we have to go to AM domain, to DG dimensions, and we can specify what is that. So we go to the AM domain, to the DG dimension, and we know that under the statutory account, we can have IFRS or local GAAP, so only those two values in our case are applicable. So this is how we make it possible to identify from the drop-down list something that we call the drop-down list potential member. This kind of annotation, it is a very simple one because we identify exactly which domain member, from which domain, and from which dimension is chosen. The template like this that we call a closed template because it has limited number of rows and columns. To be able to specify the information applicable to every single data point in this template, we use something that we call Z-axis. In fact, we have it with a gray layout in our annotated templates. So every cell in this template, it is about the solo reporting, the metric is monetary, and it is the instant data for the end of the period. What is important also is that if we have all the properties applicable to entire template in the Z-axis, then in fact the values that are identified in the columns or in the rows identifies the differences between the columns and rows. So the information shall be quite easy to read, to understand what goes where in this template and why. The second case, or the second possible way how the template can look like, it is what we call the open template. The open template, it is the template that could have theoretically unlimited number of rows. In the case, at the moment, in case of the Solvency II, there are only open template with unlimited number of rows, not unlimited number of columns. This template is organized in a little bit different way. First of all, the data points to be reported are marked with the blue color, and everything that is to the left from those primary items, we call, or there are the properties of those data points being reported on the right. First of all, we have here the type dimensions. These are this mechanism that creates for us the possibility to have theoretically unlimited number of rows. And later, we have all the descriptions as here as all members, a description or all members annotation to this value. So for example, when we have the identification code of entity, and this entity could be in some kind of a group, then we are able to pick up from the drop-down list what is the currency used for the reporting, what is the model used in this case, what is the treatment of loss absorbing capacity of technical provisions, and what is the treatment of loss absorbing capacity of deferred taxes. So as you see, this is how the information is organized. And of course, still we are able to have the information applicable to entire template using the Z-axis attribute. So let's go for a second to the slides. As you see, the components of the DPM we have already identified, but you can still see it in the presentation. So we have the owners, we have the domains, we have dimensions, we have metrics identifying the type of the data. We have a basic concepts that are very generic definition of concepts to be reported, all concepts to be reported. We have a set of different explicit domains where we have the list of those domains and the dimensions to be used in relation to subdomains which could be hierarchical. And we have also type domains and type dimensions. In every of the domains, just like in case of the lines of business, we can find the list of all members of this domain. We can see the information about hierarchy of the members of this every subdomain. We can find the information about potential arithmetical relations between members, and dimension, which is this perspective to be applicable to analyze the content of the subdomain. We have seen also what is the what are the types of annotations. So in case when we want to identify what is the metric, we have name metric and then the name of the metric. And this metric as a data type could be string, decimal, monetary, and so on. Of course, for every data point we must have one and only one metric. Then we have explicit dimensions. In explicit dimension, what is important, we have predefined values, in this case members. They can be gathered, they are gathered in domains, and domains could be later divided into different subdomains which could have hierarchical structure. Based on the explicit dimension, we can have two ways of annotating the data. Typical usage of the explicit dimension, it is identifying the code of the domain, then the code of the dimension, and the member name, which will identify exactly what is the pair of dimension, member, and the dimension. Then the second way of annotating it is this drop-down list, which we annotate using first domain code, then dimension code, and what is very important, all members. This identifies for us the information. That it is a possibility to pick up from those all members the value that we want in every case. As an option, it's possible to have the name of starting member. In this case, it's possible for us to use the existing hierarchical subdomain to identify the children of the member that we would like to have possibility to report. And the last way, or the last kind of the annotation, it is the type dimension. And as you already know, it is for those situations that we have a constraint of this breakdown, which is defined by type, not by an explicit list of the potential values. And this annotation looks as follows. It is the dimension code, and in the bracket, the information that it is type dimension. So when the template is open, as you know, we have first the information about the data point, and from the left-hand side, first we have the type dimension, then explicit dimension, and to the lower left, and in the left-hand side, we have the information about the z-axis. All the information how to read this template, you already can see in the presentation. What are the possible properties to the right or below the template? Similar situation in the closed template when we have the number of the rows and columns limited. It could be very high, but it must be limited. And also we have a possibility to identify the z-axis, which identifies the information that is applicable to entire table. As you may know, we have a large number of different frameworks or reasons or the frequency of the reporting under the Solvency II regime. It could be annual reporting for groups, annual reporting for solo, consolidated, it could be disclosure, and so on. Sometimes it seems that the templates are very similar or even look the same, but the content of those templates could be different. The question shall be how to model this information with templates that look similar. At the moment, everything depends on the content of those templates, and if the number of rows and columns and their meaning is the same. So if the meaning and the number of columns and rows is the same and the difference is just about the content of this data point, then the z-axis mechanism is enough to identify the differences. For example, as you can see here, we have one z-axis here and one z-axis here. It means that this template could be reported multiple times. Once for solo, so we can see this information as an immanent part of entire template. And the second time, it could be reported for groups. And for the groups, it could be reported in a different way because, of course, we have to, for every of those templates, then identify the group identification code. as a type dimension. And also we have to identify what kind of the consolidation it is for this group. So as you see, this z-axis mechanism makes for us a possibility to multiply the number of the number of occurrence of the template depending on its content. If it's solo or is it a group, and if it's a group, then how this group is identified as a code, and what is the consolidation method in this case. If it is impossible to use the z-axis mechanism, just like in case, for example, of TPF1 template, as you can see, the TPF1 and TPF1Q, it looks more or less similar, but in case of TPF1Q, the number of rows is limited. These rows are later disaggregated according to the different properties in TPF1, but as you see, the number of rows is different. This is why we needed to have two different templates in two different worksheets in this case. So just to make some summary, we use two different mechanisms how to multiply the number of templates. We do it using the z-axis mechanism, or we do it using the different templates in different worksheets. And the last important thing, as you will later know from the part of the presentation, the data point modeling generates some results related to a large number of the dimensions, which could be problematic, or rather could be less efficient in case of reporting the data or processing the data. This is why, or this is one of the reasons why EIOPA decided to have two different levels of models. One is highly dimensional, one is moderately dimensional. In fact, everything that I was discussing so far, it was the highly dimensional modeling, because based on that we are able to trace the value or the differences between the data points. We are able to define every and each of the data points. But to report the data and to process the data, it is reasonable to make the model a little bit less complex. To do that, we use the two layers of the DPM and later two layers of the taxonomy. First of all, as I said, we start with the highly dimensional approach, as was discussed during the previous 5 or 6 slides. And as you see, we have the information about the data type, we have the information about different properties. But let's assume that we would like to model the derivative investments other than held for index link or unit link funds, which is reported in balance sheet C1 in the cell A10A. In fact, if we would like to model this information according to the DPM methodology, according to the HD, this highly dimensional methodology, we would like to specify a lot of properties. First of all, that it is monetary. The second, that it is derivatives from the types of assets. It is the investment from investment or own use property. It is not unit link, not index link from linking property. There is a lot of different information that it is applicable here, but by default, just like lines of business, total, country of custody, total, issuer of residence, total, type of amount, carrying amount, and so on. To make the information simpler, we can identify those defaults and to say that those defaults are not necessary to be in the part of the instance to be reported. And the second thing is that part of the dimensions or the part of the properties could be merged with the metrics. So according to the moderately dimensional taxonomy, the primary item is much complex. It is not just information about the type of data or very basic information about the business content. It is already a complex information. And some of the dimensions, just like solo or group, periodicity, valuation method, are used across those two layers. So just to show you briefly how does it look in the model, let's see the proof of concept. And in the proof of concept that is also available on the EIOPA webpage, first of all, let's see what is the content of the DPM file. You will see that here we have a number of colors depending on what is dedicated to highly dimensional approach, as you see HD, mostly here in blue color. What is dedicated to MD, what we have it in green, and it's dedicated to moderately dimensional approach. Those worksheets or those domains that are applicable to both highly dimensional and moderately dimensional approach are marked in orange. And we have also some information that is commonly used, not only for the EIOPA Solvency II data model, but also other models, just like currencies, as long as we use ISO codes or the geographical areas. This can be used across different reporting frameworks, not only related to the Solvency II. So to model the information according to the moderately dimensional model, first we have to specify what is the metrics. Please mind that here the metrics under Solvency II moderately dimensional approach are pretty complex, but because of that later, the number of the dimensions that are applicable is limited. It is limited only to those domains and dimensions that are marked with orange, just like valuation general, valuation method, or the investment or own use from the portfolio domain, or the collateral guarantee, pledge as collateral from the collateral guarantee domain, or lines of business, and so on. To know what is to be used according to highly dimensional methodology, first of all, we have in the highly dimensional methodology metrics that are identifying only the type of the data. Then we have the information about the basic concept. As you can see here, the basic concepts are very simple, are very generic, and all other information is divided according to the different properties, and those properties you have in the blue worksheets that are dedicated only to HD approach, and of course orange that are applicable to both. So as you see, we have two different parts of the data model, one for the highly dimensional, one for the moderately dimensional approach, part that is common for the highly and moderately dimensional, and part that is marked in yellow that could be common not only to the Solvency II regime, but also some other regimes. We have also annotated templates according to those two different approaches. So again, according to the highly dimensional approach, here colored with blue color, and moderately dimensional colored with green. So just to compare how does it look like, we said previously that in fact the templates to be annotated are exactly the same, but one dictionary is much more simple according to the more moderately dimensional approach. One is more complex and gives you a potentially information about every difference between every single two data points in the model, which is highly dimensional. So you can see that exactly the tables look the same, but according to the highly dimensional, we have a lot of properties identifying every single aspect of the information. And according to the moderately dimensional, the metrics already include the information from many different sets of even different or even not related data. But based on that, the information is much simpler. That would be potentially all from my side. I will pass the mic to the Bartosz. But before we do that, I guess that's the other session when you can have some questions. So I'll pass to Aitor for monitoring that.
Yes. At the moment there are no questions. It's the moment for questions. If anyone, any question? Okay, seems that there are no questions. Bartosz, you can go ahead.
Okay, thank you, Aitor. So the next part of the presentation is devoted to the proof of concept taxonomy. So we'll switch from the data modeling to more technical things, which is how all this stuff was expressed in XBRL format. The first, very briefly, I would like to discuss how the process looks. So as Michael discussed, we start from information requirements. So the templates and the business logs, and these were prepared by business users and tried to resemble what is in the legal acts. So the next step was to develop a data model, so identify the breakdowns and their members, and also to annotate the templates. And out of this input, the next step is to create a taxonomy. So translate the breakdowns and members into the declaration of primary items, dimensions, explicit and type dimensions, domains, etc. Then also to define what are the logical combinations, what is the rendering, so how to get back from the detailed properties to the rendering of the tabular views, and also how to express the business rules so that they can be validated automatically. And basically for the taxonomy, as you know, the data is exchanged. So filers prepare instance documents, which are reports in XBRL format, that are built according to the rules defined in the taxonomy. So they have to use the concepts and dimensions which are expressed in the taxonomy. And later the data is stored after being exchanged, analyzed, and of course supervisors and other analysts take decisions based on this data that may further impact the information requirements, and the process may begin again. So after some time there are next iteration of the legal act of the data model and taxonomy. Now taxonomy itself, as described by Michael, is split into two parts similarly to the DPM. So we have a dictionary part, which is the DPM listing all the business properties and the hierarchies. And there is a template part which defines the current subset of data points, so the tabular views, representing what is required to be reporting at the moment from the entire universe of possibilities. So this is the logical split in the taxonomy level as well. It resembles in the same way the split made in the DPM and the annotated templates. As Michael also said, the dictionary part is divided. So we have some definitions which are cross-sector. So potentially these business terms that can be reused not only in insurance, but maybe also banking, securities, and other regulators can apply the same breakdowns. The usual suspects here are obviously the currencies and the countries identified by ISO codes, but maybe with time it will turn out that some other dimensions, some other breakdowns can also be shared, such as sectors or different risk types, which probably will be common for different purposes of gathering and exchange of data. The second level is Solvency II common concepts. So these are the sets of items that extend the cross sector and can be used by both versions, the Solvency II highly dimensional and moderately dimensional. And this helps a lot in the reconciling between the two models. So these properties that are exactly the same are simply defined once and reused in both layers, rather than declared two times and then some kind of link and connected to identify this relationship. And on the dictionary level, both the highly dimensional and moderate dimensional extend the common concepts. And obviously the extension is much higher in terms of highly dimensional taxonomy, because as Michael showed you, there are numerous dimensions and the domains and members added on this level. In terms of moderately dimensional taxonomy, the main extension point is the metrics. So the number of primary items, those basic terms, is much longer in terms of moderately dimensional taxonomy, as it combines the semantics that in highly dimensional version is carried by the dimensional elements. And the level below is the templates. So templates resemble the current information requirements, and they are constructed in the same way as Michael showed you. So the annotated templates are translated into the rendering link base, which I will tell you later on, and the data points are described using the definition link base, which is the hypercubes in XBRL, which basically identify the valid combinations of the properties, saying that certain metrics can be applied with certain dimensions or not. And then how this is all used? Obviously both versions, the MD and HD, can be used for reporting, but as stated before, the purpose of the moderate dimensional version is to make the reporting easier by defining simpler taxonomy and also by limiting the size and the complexity of instance documents. This shall improve the performance of processing the data, because the instance document, the reports, shall be smaller, and the execution of the validation rules should be faster. But if some filers have more advanced systems, it may turn out that for them, using the highly dimensional taxonomy to produce the instance document may be easier, because they can apply exactly the same breakdowns as defined in the taxonomy, or they already apply the same breakdowns in their internal systems. So they can map one-to-one between the properties rather than mapping to the data points. Then there is the conversion layer that is provided. So at any point of time, anyone should be able to know how the data point is expressed in the MD and HD version. And this can be read easily from the rendering. So a cell in one table over here is described in XBRL in the same way as this cell in the table over here. But you can see what are the different properties hidden behind these cells. I will show you that in a moment on a few examples. So rendering is one way of showing the relationship, and the second way is the formula specification, which for the POC was also created, which allows for conversion of a highly dimensional instance document into the moderately dimensional instance document and vice versa. This means that when a filer uses the simplified approach to create the instance document, at any point in time, he or she can convert it automatically to the highly dimensional and vice versa, depending on which solution would be chosen by to support the reporting. It's possible for filers to apply the alternative solution and apply the conversion to produce the required result. And the HD approach, so the taxonomy, which is highly dimensional, is more likely to be used later for analysis, because it resembles one-to-one the data model, and the data model is built explicitly applying consistent breakdowns, which shall easier the analysis part, querying the data based on the sets that are already predefined. So to recap, these are the main differences and the main purposes of the two layers. So HD is reflecting the model. It's explicit and consistent in application of the breakdowns defined in the DPM. It also supports significantly the change management. As Michael discussed, when introducing a change in the highly dimensional in the DPM, a user must not only look at at how this new item impacts the existing hierarchies, etc., but also make a huge change in the templates may have no impact at all at the DPM, because the breakdowns and members that are already defined can be applied to express new tables. While an empty version, as I said, taxonomies and instance documents are smaller and simpler, and the performance should be much better. The architecture of the taxonomy, as Michael said, the DPM at the moment defines also the POC DPM defines 4 different levels. So the cross-sector, the Solvency II Common, the HD, and MD. And in taxonomy resembles the structure by defining concepts in different places. It means in different sets of files and folders. So if you look later on, I will show you that the POC taxonomy starts with folder names that indicate what are the items, what is the owner of the items defined in a particular set of files. The taxonomy, as I said, is divided into two parts logically. One is the dictionary, where we have the metrics together with the hierarchies of the domains split into explicit and typed. Each explicit domain has its own folder, which lists all the members and puts them in the hierarchies. And there is a set of dimensions declared that refer to explicit or typed domains. So this is the dictionary part. And then we have the frameworks part, which identifies what is the scope of the reporting. There is a version date, which says what is the applicable, what is the version of templates or the taxonomy version that this is the taxonomy defines. And then there is a tab folder, which consists of all the tables. So each table is defined in a separate folder, defining the rendering and the valid hypercubes. Modules import the tables depending on what are the so-called entry points in the taxonomy. For example, there could be an entry point for solo reporting and a separate entry point for consolidated reporting. And in case the tables are different for solo and consolidated, there will be different templates imported by different modules. And the val folder defines the validation rules. As Eric will explain later on, these validation rules are also defined in sets. So there is a set of rules that applies to a particular table, or maybe there are rules that are cross-table. These rules are always defined in the files that resemble their application. And from the technical perspective, each of the schema files defines a namespace and prefix. Namespace is a surname for all the elements, and prefix is abbreviation of the surname. This is what helps us identify the concepts that belong to a certain owner, so that we don't mix the concepts on the common cross-sector and the common Solvency II items. So in the set of files that was distributed for the taxonomy Solvency II PoC, there is a taxonomy folder. And it starts with the HTTP folder, because at the end all these files will be stored somewhere on the internet. It has three different subfolders. The Eurofiling and XBRL.org are the subfolders that contain technical files that are reused in our example. So in case you're using XBRL tools, you may need to apply certain remappings to access certain files from the XBRL.org specification, or some Eurofiling files that are also shared with the EPA that define some properties of the model. The most important part for us is the example.com, where all the taxonomy files for the PoC are stored. There are 4 folders, each representing different owner, so cross-sector, Solvency II Common, HD, and MD. And there is the conf folder, which I will talk later on, which contains the files that define the formulas converting the HD instance document to MD instance document and vice versa. Why do we define it this way, that HD and MD are separate sets of files? The reason is that mainly the performance. Because we want to allow MD to be fast performance, it doesn't make sense that MD imports any of the HD taxonomy files. Because MD uses fewer dimensions, it doesn't make sense that all the HD dimensions are imported by MD taxonomy files. That's why they are totally separated. There is no connection between these two folders, apart from the conf folder, which defines all the links between the data points. And I will discuss this also in the moment. So if I go to the Solvency II MD, what I will say is that I have 2 files. I have the 2 folders, the dictionary and the framework. Framework in this dictionary defines only the metrics. In case of HD, there will be also the domains. And the framework folder defines the taxonomy version, the tables. In this case, we have the tables listed over here. the modules, so the entry points. This is also where we store the sample instance document that I will run in a moment, and the val folder, which defines different rules. And as you can see, these rules are also sometimes cross-template, sometimes applied to a single template, and so on. So going back to the presentation, knowing how the taxonomy is structured in folders and files, the next thing I would like to discuss is, I think very important, is the rendering of tables and valid combinations. So this is something that is defined in the folders, in the folder for each table, and it expresses the content of the table using XBRL syntax. So rendering is the specification being developed at the moment, which defines how to get back from the DPM properties to the original views of tables. If you imagine a table on the bidimensional space, you will see that what it has is it has some headers of columns and headers of rows, and maybe a header of table that can have some drop-down lists. In XBRL specification for rendering, this is called axis. So we have y-axis, x-axis, and the z-axis, which is the header drop-down information, which is optional. It's not mandatory to have this one. The x-axis and y-axis are mandatory. Then each axis consists of ordinates or nodes. These are each particular header of column or header of a row. In this case, we have an x-axis with 3 different ordinates. They can have labels and references. I will talk about it in a moment. And also, these ordinates or nodes can be nested. So we can have a parent-child relationship between the headers in the same way as we have it in the original templates. Moreover, we can say, in case of nesting, if the parent element should appear before the children, after the children, or if it should be abstract, so it's only a gathering header, it doesn't result in additional row or column in a template. There can be multiple axes of certain kind, so we can have many x-axes, many y-axes, or many z-axes in a single table. In case of many x-axes which are fixed, what we end up with is a Cartesian product, so a combination of headers, ordinates from one axis and the other axis. This is not very common. What is common is that we have multiple y-axes in case of open tables. So we can say that each instrument is characterized by a currency, by a geographical area, etc. And these axes, in that case, can be open, which means they don't have to list all the members. Instead, they will filter and display whatever is filed by the filers. In the same way, the filers are able to pick some properties from some kind of drop-down list to add additional row in such table. Similarly, the z-axis can be there can be multiple z-axis. When we have a drop-down list, the result is the multiplication of occurrence of a template depending on the number of possibilities on each z-axis. And the next thing is the valid combinations. As you can see in many templates, what we have is some kind of crisscrossed or gray areas. The rendering itself defines what is in the headers of columns and headers of rows, but what it also can say is, combined with the definition link base, it may say that some information is excluded from being reported. So there is central information in the header of a column and header of a row, and for this particular intersection, it's not applicable. It means it must not be reported. This information comes from rendering, from the dimension specification, and it's defined in a separate file of the taxonomy, which is called the definition link base. And looking at the general example of what we can have in the rendering is, in this table we have one x-axis, which defines here the headers of columns, one y-axis, which defines the headers of rows, and we have two z-axis. One is just a header, and the second one has two possible values. These labels here could be replaced by any text. It means it could be, for example, lines of business, and then the nested headers can contain particular lines of business applicable in this particular table. Similarly, for the headers of rows and the headers and the possibilities on the drop-down list. Moreover, what is hidden behind each header is not only the label, but from the DPM we identify what dimension and member is there. For example, label 1 is this particular information in this column. It consists of dimension A and member A0, as well as dimension B and member B0. This information, if it's in the upper level ordinate in rendering, is inherited by lower level ordinates as long as it's not overridden. It means that in this case we have A dimension with A0 member, which in label 4 was overridden by A1 dimension A4. So this is how we can override and make sure that one property appearing in this column can be overridden by another property in this column, and so on. Moreover, what we also can have here is some kind of reference to the period, saying that information is in row 1 over here is the same as information in row 6, but the difference is that this one is at the beginning of the period, while this one is at the end of the period. The other functionalities that are applicable in the rendering, but not necessarily used by EIOPA, is that each row and each column can have a reference. What I mean by reference is a legal reference, for example, to a legal act or some other guidelines, and the row code and the column code. So these are additional properties that can be added if necessary to identify the rows and the columns. And as you can see, the grayed out area or the crisscross area in this table, it results from the hypercubes that are associated with this file defining this rendering. So the hypercubes say that, for example, combination of dimension D member D1 and dimension B member B2 is prohibited. That's why this particular cell is not possible to report this particular cell. So that's the mechanism that we use at the moment, and that to express the tabular views and the valid combinations behind these tabular views. Before I go into some real examples, when I show you some tools, I would like to show you how this rendering works on the slides. So this is the template VSC1. As you can see in the version above, this is MD version. How you can learn that? Simply by checking what is the metric and what are the dimensions. In this case, the metric is not just expressing the data type, but it also contains some semantics. So this is participation, investments other than assets. Then the two-dimensional values, so statutory count is expressed in the header of column, and solo comes from additional information on the z-axis. In case of the same table, exactly the same table represented in the HD version, you can see that the number of properties behind the cell is much longer. So it's the metric is just monetary, and information about the participation, investments, other than assets is split by a number of properties. So we can say that this is assets, who is the counterparty, what is it investment or use its participations, type of assets, the equity instrument, and so on. So these are the properties that are necessary in HD to express the content of the cell. And by any time I can go and check how this property over here relates to other properties from the counterparty breakdown, or how the participations relate to other properties from the investments and own use. In case of MD, it's much simpler. So we have a single line and only two dimensions. Similarly, in the template for the DSC1D, where we have also a list of currencies, this particular cell highlighted in red in the MD version is described as the metric reinsurance recoverable assets, and then we have 4 different dimensions, and you can see that the number of dimensions in HD version is much longer, but some of the dimensions, as you can see here, for example, consolidation scope, original currency, threshold for mature currencies, or valuation general, are exactly the same. The added dimensions are simply extending the base monetary to resemble reinsurance recoverables assets. And this is also the case of open tables. In this case, we have asset D1, which was normalized, as you can read from the documentation, into part 1 and part 2. this is part 1, and when I pick up this particular cell in the HD version, I can see that this column is expressed by the item, by the memory item, and then the properties. Some of the columns in this table become properties. So ID code, fund number, portfolio, etc. are properties of every of these 5 different data points. In the MD version of OpenTable, the property that is there is only the one needed to distinguish each row uniquely, and one of the properties is an internal code added to distinguish each row uniquely. So then the number of columns that resemble data points is a little bit longer. And you can see that the dimensional values applicable for the particular cell in HD and MD are as in the other examples, where MD is much fewer dimensions and more complex metric, while in HD is very simple metric, and the information from the semantic of the information is distributed among different dimensions. And the last table that is part of the PoC that Eric will discuss later on is filing indicators. In this table, simply the filer identifies which table were submitted together with the package, which allows for checking which rules needs to be executed in order to not to check too much on the data that potentially was not reported. So let's play a little bit. So I will now try to show you the taxonomy in tools, which means that there is a high risk of something going wrong. Hopefully everything will go fine. So first, what I would like to show you is the DPM architect. So the tools that we used for development of the taxonomy. It's a tool that was currently shared by the Bank of Spain, and the plan is that this tool will become an open source available tool for everyone later on. So I can open the model, which is the EIOPA PoC for Solvency II, and right now what it loads is the taxonomy files. So it's opening the taxonomy. It will show me 3 errors if I'm not wrong, but this is not an error. It's just a thing I changed the taxonomy at the last stage, which is not in the tool, so don't worry about it. So the first thing what I have is the owner. So if I go to settings and session options, what I can see is the owner. So I'm able right now to say if I want to define the concepts that are on the cross-sector level, so shared between banking, insurance, securities, or are on the common level for HD and MD, or are specific to one of these 2. I'm not defining anything at the moment, so I can skip this step. And I can see what are the metrics. So what are the base items defined in the model. As you can see, the number of metrics is quite high, and this is simply because I have here both kind of metrics. I have the metrics that are the moderately dimensional metrics, and I have those that are highly dimensional metrics. If I order them by name, I can see that most of the metrics are moderately dimensional, and the highly dimensional are just a few, like date, decimal, or integer. There are a few metrics which are common, and these are the filing indicators which are used in both versions of taxonomy, which means that this table where filers say which template they have submitted is the same items used in both versions. Metrics, apart from their definition as the list, and looking at the DPM files that were previously showed by Michael, I'm right now resembling what is in the metrics for the Solvency II common items, the metrics for the HD version, and the metrics from the MD version. You can see that on the right-hand side, Michael was showing that there are also some hierarchies, saying that what are the calculation or potential aggregations between the metrics. The same as in the taxonomy. So if I go and try to edit the hierarchies, you can see that I will see the hierarchies defined either for different templates, and also, if applicable, identifying the aggregations, saying in this case that equities, investments, others, and assets, etc. is equal to the listed and unlisted equities because of the value of the weight on the relationship. The sign of the comparison operator can be either greater, smaller than, or equal than, like greater or less than the value of children, and it has impact on the way the taxonomy is modeled. So you can see that in some cases it's not the equal sign, but greater or less than. Then I'll go to the domains. So this is where all the domains are listed. The domain that Michael was discussing heavily was lines of business. So let's take a look at this one. If I look at the members that are there for the PoC, you can see that all of them are, most of them are highly dimensional, and 3 of them come from the common part. So these are shared between the HD and MD. These are only applicable in the HD version of taxonomy. Here I have the labels. I can also set their validity in time, etc. So these are the other properties that will be discussed in the future, how to manage this information. At the moment, what is important is that I have a list of domain members for lines of business, and I have the hierarchies saying how the lines of business aggregate or not, depending on what is the type of relationship, from the lower level elements to the upper level elements. So in any case, there is a difference, there is a change in the template, and there is a new lines of business added. The user not only needs to look at the list of the domain members, but also has to place this new element in the hierarchy, which is very important because it allows the model to be clean and not messing 2 different things in one set of items. At any point of time when I need to put something inside of hierarchy, I have to tell how it's different, how is this new item different to the existing relationships. And this helps in management. And then at the end, I have a list of dimensions. Some of them are typed, as you can see by the color. So this is the CIC code, which is some kind of code, or external rating, which could be some kind of rating, but there is not an explicit list of ratings defined in the taxonomy. And at the end, I have frameworks. So I have the HD version and the MD version. So in the HD, let's open one of the tables. So I have here 3 tables, which is the PSC1, PSC1D filing indicators, and I have the assets D1 table split in part 1 and part 2. If I open the highly dimensional balance sheet, I can see that right now it looks like a hierarchy because this is how the XBRL in rendering in XBRL is built. So I have 2 columns, statutory Solvency II value and statutory accounts value, and I have rows, as you can see, as nested ordinates, as explained before. So these are 2 different axes, x-axis and y-axis. And behind each cell, I can see what are the properties. So behind the row identifying pension benefit surplus, what is here is this set of properties, dimensional properties, and if needed, I can change any of them to a different value for each of the particular domains. This is not a very nice look of the table, so what I can do is try to see the table in the p-dimensional space. So right now the tool rendered it so that it shows me the table as it is exactly in the template of the PoC. So the structure of nesting, etc., should be identical. And when I click on any of the headers, it will tell me what are the properties, dimensional properties in here. If I click on any cell, it will merge the information from the headers of columns and headers of rows and display all different properties. This is a table for HD version, as I showed you, because it has a number of properties. For the MD version, the same table. If I click on any of the cells, you will see that it has only very few properties. So that's the main difference between these 2 different versions. And now this is the place where the taxonomy is built. So in fact, what we do is we try to resemble the data model defined by business users using these different constructs of metrics, dimensions, domains, And in the framework, we define the tables and then modules, which are the entry points as discussed. So these are the files that import particular tables depending on the application for certain type of entities or for certain frequency of reporting. Now, maybe let's finish with that. I will show you one more tool, which is RL. It's an open source XBRL platform developed in Python. Here I can also open the taxonomy file or maybe an instance document. So this is the taxonomy that is in the PoC. If I go to the MD approach, for example, to the frameworks and the modules folder, I get some instance documents. They are of different size. Let's start maybe with a small one. If I open it, the tool loads the taxonomy and renders the table based on the rendering defined in the rendering namespace. So this is a table where I have defining indicators when I'm able to select if it's true or false, so which tables were submitted. Let's maybe change to the balance sheet table. So this is the BSC1, and I have the numbers from the instance document. You can see that at the moment the tool shows that these two cells are reportable. If I look into the templates, I will see that in fact they are prohibited. So what I need to do is to turn on, and basically most of the tools do it on the beginning. This one lets you turn it on and off, dimensional validity. So now there is a property in the rendering that defines this row and this column, and in the hypercube's description of this row and column is missing. So if I turn on the dimensional validations, it will not allow report of these two items. If someone sends this item, there will be an error in XBRL showing that these two items are dimensionally invalid. So that's how it looks. I can change the view maybe also to other table, which is the one containing all the currencies. So it's going to be quite a long table. Just a moment. And I'm also planning to show you the formulas. So how so this is the table where we have all the currencies defined, and the filer can input the values for the BSC1D. And in the formula, what I have is the business rules. So here I have description of what is the test. There is also a possibility to display a label, which is not made in this case, but it tells me that there are some variables, BSC1A4, A3, and A27, and there is a rule between these three different variables, which are defined over here with the name of the metric and some dimensional properties if applicable. So there is a set of different rules applicable for different templates, and at any point of time these rules can be checked against this instance document. So if I click validate, it should go through the rules, validate the taxonomy. It will take a second because it validates all the stuff at the moment. And what I should have at the bottom is the list of all the rules and whether they were satisfied and how many times. Other tools also show these rules in the rendering, so they can show that basically on the cells that are affected by the rule being evaluated positively or negatively. So this is how it looks from the instance preparer side. So if I'm open taxonomy, change back to the C1 template. So if a filer changes any data in the instance document, so apply some modifications, they can always save it as the new XBRL file and submit to the supervisor. Now let's try again. I'll close all that, and I will show you how the formula conversion works. So instead of opening the instance document from the taxonomy, I'll go to the conv folder, which contains the conversion files. So I have conversion formula link base for every single template. Sometimes the conversion is made data point to data point, meaning each cell to each cell. Sometimes it's much simpler and defines only the distinctive features. So it's like a conversion from the from the MD metric to HD metric plus the dimensions that were included in case of MD in the definition of the primary item. You can see here that what we were saying before, that the instance in case of HD taxonomy and MD, the size is different and also its complexity. The MD instance document for exactly the same scope is 123 kilobytes. In the case of HD, is 669. So that's the difference. But let's say that I produce the HD instance document, and I will open it. Just a second. It also shows me the rendering as in previous version, but right now it is using the HD taxonomy, and I want to convert it to the MD version. So I click validate. It's now checking the taxonomy. It's also evaluating the formula, which I will show you in a moment. So right now it's evaluating all the conversions from the HD to MD version of the instance document. So the formula was written here, and it says what are the input and the output, and this is the output instance document. So it converted the instance document from the HD version, which is expressed in these tables, to the MD version. So now I can copy it and open again, and it will open the MD version of the instance document. So this is the main component of the PoC taxonomy. So maybe now we can check if there are any questions, and we can continue with the last part.
Hello. Hello, Eddie. Thank you very much, Bartosz. Seems that still without question. There are attendees, but no questions at all. Hello, Eric.
Hello. Good morning, everybody. So I'm Eric Jarry from ACP, and I want to introduce some consideration, topics, issues that are related to the taxonomy. Okay, the first one is BSC1, as you've seen, as Bartosz has showed you. For BSC1, we have changed from the previous taxonomy. We have introduced the variation as a dimension. So we have variation general, which has a value either of Solvency II or statutory account. And if it's statutory account, it should be a new primary item showing which kind of statutory account we are using. Are you using German GAAP, Polish GAAP, French GAAP, or whatever, maybe IFRS. So for the time being, in the QWERTY, we have two different codes in the two columns in BSC1. In the new taxonomy, we have a single code, and the QWERTY will in fact be aligned to the DPM and the taxonomies. There were also some specific feature in BSC1 with dotted line. When you have a dotted line between two cells, it means that either the sum of the two cells should be reported, or it's possible to report the detail. Okay. It's very difficult to model that in XML, and I think it's not a good practice to do that. So the idea is that in this case, we have introduced a total cell, okay, and the filer, the undertaking, has a choice either to report only the total or to report the total and the details. For validation, it's not possible to report only the details. For example, we have an example for equities, so we have added this element, which is the total over the QWERTY. Okay, so this is A7B. Okay. Next slide, please. For BSC1D, so BSC1D is an optional template, which is a breakdown of some elements of the balance sheet by money. And in fact, the breakdown is done by currency up to a total of 90% of the assets and liabilities. Okay, so you have to report all currencies, for example, for euro, Polish zloty, pound. Okay, and this is if these three currencies are up to 90%, you report all the other currencies as the other column in the QWT template. Okay, so with the DPM, it's not a good practice to use other. So you have to define what is other. So the idea was to introduce a new dimension, which is called threshold for material currencies. Okay, which will take two values, superior to 90% and inferior to equal to 10%. Okay. In fact, there is also a total, which is a default value, and the other column, in fact, corresponds to all currency, provided that their threshold is less than 10%. Okay. We also have to refine the name of this value, because it's possible for an undertaking which has a limited number of currency to handle to report all currencies, even if they are below the 10% threshold. Next, please. For BSC1D, there is another consideration. In the DPM work has determined that some items were common between BSC1 and BSC1D. Okay. For example, the first two ones are some kind of investments. The third one is derivatives, and the fourth one is contingent liabilities. Okay. So in the taxonomy, of course, for the highly dimensional taxonomy, we'll use a monetary primary item plus a set of dimensions corresponding to the characteristics. In the multi-dimensional taxonomy, we will use the elements of BSC1. Okay, so BSC1 DA3 will no longer exist. Okay, the undertaking will report only one fact covering both templates in this case. I recall that BSC1D is optional, so we'll come back to that later. Next slide, please. Thank you. So as Bartosz said, in fact, we have normalized this template, because in the QWT, each line of these templates represents, in fact, two objects. The one object which is the asset, in fact, and the other one being the line of asset or line of portfolio. Okay, so if we would model taxonomy like the template, we would have a lot of duplicate information in this in the reports, and we would have to in fact validate that the elements are consistent. Okay, so the idea is to normalize this template and to define two tables. The first one being a line of assets table with two key, I would say, two dimensions, which are more or less a key. Line of assets identification, the key. In fact, this identification is internal to the undertaking. And asset identification, which is a foreign key to the second table. Okay, so for those who are familiar with relational databases, it's in fact a normalization of this table. Next slide, please. Enumerations. Okay, we have in XBRL you have a problem with enumerations. Typically, enumerations are provided as XML enumeration, and it's not possible to define labels to this each enumeration value. For example, yes or no, we should have a label in French, for example, oui and no. So and more complex enumeration would need to have labels in different languages. So I think that PRG has a good idea to use QName for this enumeration. Okay, so we define the enumeration as a domain, like a domain using a dimension. Okay, and we use the QName of each value as the value for the enumeration. This approach has also the advantage that it's possible to share an enumeration to both a primary item and a dimension. For example, for countries in some templates in moderately dimensional taxonomy are used as primary item, and they are also used as dimensions. Okay, so with this mechanism, it's possible to share the same domain and to avoid duplicating information. And for enumeration like countries or currencies, it could be a lot of values for these domains. In fact, Bartosz just told me that this mechanism is under consideration by XBRL International, so it could be a way to have a standard way to process them. Okay, so next slide, please. Restriction on sample XML type. As Bartosz told, there is a very limited number of metrics or primary item in the HD taxonomy. So for example, we have string and we have decimals, and this is kind of value. In fact, we need to restrict the possible values. Okay, in the previous taxonomies, we were using restriction in XML. So for example, we restrict a name as being a character string of less or equal 150 characters. Okay, this has a drawback because in fact when there is an error, the instance is rejected as being XML invalid at a very low level. So it's not possible to process this instance even if there is only one character more in a name. Okay, the instance has to be rejected, and the undertaking has to fill the report again. Okay, and this using in fact assertions to check this restriction on different types has a lot of advantages. Okay, first it's avoid this problem of rejecting instances, and then it's allowed to have a very comprehensive, understandable message. Okay, for example, unless instead of having XML error, we would have names must be limited to 180 characters, for example. Okay. Next slide, please. Assertions. Okay. So assertions, XBRL assertions are a way to provide business validations. Okay. So the practice that we will be using in this taxonomy in EIOPA will be that each assertion will be identified, okay, with a code, which will give the template of the context of the assertion. For example, this assertion is performed in the context of BFC1 or BSC1D. Okay. The type of assertion, so afterwards you will see the possible value for the types, and a rank number that allows to have a unique number for the assertion in the taxonomy. Assertions shall also have a meaningful label. For example, A shall be equal or must be equal to B plus C. Okay. So it's possible to discuss between business people about this assertion if it's not satisfied. Okay, how to handle it. And optionally, a tolerance margin. Okay. There is currently work in progress in EBA on this topic about tolerance margin, and maybe we'll use something which is called interval arithmetics, which allow to give for each fact possible margin. Okay, and the margin for the assertion will be automatically calculated. Okay, so this is work in progress in the EBA, and maybe the EIOPA taxonomy will take this approach. If it doesn't work, or if there are some drawbacks, we can use a simple tolerance margin, for example, a percentage on the value, or maybe a fixed number for these tolerance margins. For example, for an assertion, we may have the code BUSC1 P400. So this means that this is an assertion in the context of BSC1. Okay, it's a primary item assertion. Okay, and the number is 400. Okay. The label would be aggregation to loan and mortgages, except loans or policy. And in fact, this assertion will check that BSC1A14, okay, is in fact equal to BSC1A14B plus BSC1A14C, with some tolerance margin with the dimension value only Solvency II, because in fact the breakdown doesn't exist in the statutory account column. So the PoC contains a limited set of assertions which show in fact the various types of assertions that we have. Next please. The first type of assertion is a primary item aggregation assertion. So in the modality dimensional aggregation, we have primary items, which are the concepts that are used by business people, for example, investment, derivatives, property, plant and equipment, and so on. Primary item aggregation assertion checks that the total primary item is the sum of its breakdown. Okay, for example, the example I just gave, BSC1P400, we check that the aggregation to loan and mortgage is equal to the sum of its breakdown. In fact, it will be limited only for Solvency II column. Next, please. The next one is the dimensional aggregation. Okay. So, for example, in BSC1D, we have a table with a set of rows, okay, and columns. In the columns, you have a list of currencies, and maybe one currency is some more or less other. Okay, I explained this previously. And with this assertion, we check that the total value of the total column is equal to the sum of all the other columns. Okay. And this assertion is valid for all primary items. That's why it's called a dimensional aggregation and not primary item aggregation. So the code in this case would be BSC1D, meaning that this assertion is done in the context of BSC1D and D100 for the identification. Okay. Next slide. Value check. As I told you previously, we have to check some business rules which are not aggregation or in primary item or dimension. In this case, we check that the total Solvency II amount is equal to the quantity multiplied by the unit price plus the accrued interest. Okay. In fact, this is the check which is below in the third bullet, excuse me. And in fact, we will have some tolerance margin as well. So this assertion is in the context of ASD1. Next one, please. Type check. Okay. This is an example. We have some primary items which are in the context of ASD1, which is. Do you have it? No, you don't have it. Okay, so we check that these values are for A22, A23, and A30, excuse me, are all positive. In fact, it's the total per amount, it's the Solvency II price and accrued interest, and all these items should be positive. Okay. So we don't use restriction on the monetary type. Okay, we use an assertion. So we have a label. Okay, and if this is wrong, we will have the information that is in the context of ASD1. You have a problem with non-negative monetary item. Next one, please. Value check. This one is similar to the previous one, except that this assertion is done in the context of both BSC1 and BSC1D. Okay, so this means that both the templates BSC1 and BSC1D has to be filled. Okay, since BSC1D is optional, this assertion will have to be exercised only if BSC1D is filled. Okay, so that's why we have introduced the concept of filing indicators to be able to check values only if the corresponding template is filled. Okay. Next one, please. So we are back to filing indicator. So this indicator, there is one indicator for each template. Okay, this is a Boolean. Okay, in fact the default value should be false. Okay, so when this filing indicator is set to true, okay, in the report, in fact as Bartosz showed previously, it is in the taxonomy. It means that the data has been filled. Okay, so it's possible to check to check the validity of this data. Okay, and to exercise, in fact, the assertion in the context of this template, and in the context of these templates plus other field templates if you have cross templates assertions. Okay. So as written in the last bullet, okay. So this assertion BSC1, BSC1D, V100 is evaluated only if both BSC1 and BSC1D are recorded. Next one, please. I think we are at the end. Thank you. So do you have any question on these topics?
There are no questions, Eric. There are more than 50 attenders, but they found questions. Okay, that's all I think. Thank you very much. I think that we did a really detailed explanation, and we're going to try to share this video also with the members and everything in the world. Thank you everybody for attending the meeting. Thank you very much.